Did you know that Jupiter's Great Red Spot, a tempest larger than Earth itself, has been churning for at least 400 years? Picture this, a storm so vast that you could fit our entire planet inside it and still have room to spare. That's Jupiter's Great Red Spot for you. This tempestuous feature was first spotted in the 17th century, and it's been swirling ever since. It's not just a passing squall either. This is a storm that's been raging for centuries, making it the longest-lasting known tempest in our solar system. The sheer size and longevity of the Great Red Spot are mind-boggling, even by Jupiter's standards. Jupiter is the largest planet in our solar system after all, with a diameter over 11 times that of Earth. Yet, even on Jupiter, the Great Red Spot is a standout feature, measuring twice as wide as our home planet. But what makes the Great Red Spot truly fascinating is its composition and color. This isn't a storm of water and wind as we know it. Instead, it's a swirling maelstrom of hydrogen and helium, the same elements that make up the Sun and most of Jupiter itself. The storm's iconic red color is a bit of a mystery. Some scientists think it's caused by chemical reactions in Jupiter's upper atmosphere, where the Sun's ultraviolet light breaks apart chemicals like ammonia and methane. These broken molecules may then reassemble into complex compounds that absorb sunlight and give the Great Red Spot its reddish hue. So, the Great Red Spot is not just a storm, it's a window into the exotic chemistry and physics of a gas giant planet. It's a reminder of the awesome power and scale of the natural world and of the many mysteries that still lie beyond our reach. So that's the Great Red Spot, a true spectacle of our solar system. It's a storm like no other, a whirling, churning testament to the power of nature and the enduring mystery of the universe. This grand tempest, larger than Earth and older than any storm we know, is a vivid reminder of how much more there is to learn about our cosmic neighborhood. Ever wondered what makes the Great Red Spot, well, so great? To answer that, we must delve into the anatomy of this fascinating storm, a storm unlike any we've ever seen on our home planet. Let's start with the storm's wind speeds. Imagine a hurricane on Earth, then amplify its power by a factor of 2, then 3, then, well, you get the picture. The Great Red Spot's winds are fierce, reaching speeds of up to 300 miles per hour. That's 3 times faster than the most powerful hurricanes ever recorded on Earth. These winds, however, don't just whip around aimlessly, they form a counterclockwise rotation, creating a vortex that's larger than our entire planet. Now, where does all this energy come from? You might think it's the sun, but that's not entirely true. While solar radiation does play a role, the primary energy source for the Great Red Spot is Jupiter's internal heat. This heat creates atmospheric instability, which fuels the storm's powerful winds. It's a bit like a pot of water boiling on a stove. The heat source, in this case Jupiter's internal heat, causes the water or the atmosphere to churn and bubble, creating a storm. But what about the storm's longevity? Why has the Great Red Spot persisted for at least 3 centuries, while storms on Earth last for just a few days or weeks? Scientists believe that Jupiter's lack of a solid surface could be a key factor. Without land to disrupt the storm's path or absorb its energy, the Great Red Spot can continue to churn indefinitely. The Great Red Spot's sheer size, its power, and its longevity are all part of what make it so fascinating, but it's also a reminder of the dynamic nature of our universe. This storm, in all its fury, is a testament to the unending and ever-changing nature of the cosmos. From the smallest dust particle to the largest storm, everything in our universe is in a constant state of motion and change. The Great Red Spot in all its fury is a testament to the dynamic and unending nature of our universe. Shift your gaze from the storm and you might just spot Jupiter's secretive ring system. As we move away from the tumultuous storm, we find ourselves drawn to another fascinating feature of Jupiter, its ring system. Unlike Saturn's flamboyant rings, Jupiter's are a bit more on the down low, keeping a low profile in the cosmic neighborhood. The discovery of this ring system came as quite a surprise. It was the Voyager 1 spacecraft in 1979 that first stumbled upon these elusive halos. The rings were faint, almost ghost-like, and composed mostly of tiny dust particles. This dust, scientists believe, could be the remnants of meteoroids that crashed into Jupiter's moons. Now let's take a closer look at these rings. There are 4 main rings: the halo ring, the main ring, and 2 gossamer rings. Each of these rings has its own unique characteristics that make them stand out in the crowd. The halo ring closest to Jupiter is thick and cloudy, a soup of fine particles that gives it a foggy appearance. The main ring, on the other hand, is relatively bright and narrow, consisting of larger particles. It's like the showstopper of the group, catching the eye with its relative vibrancy. Then we have the gossamer rings, named for their ethereal, almost transparent nature. These two rings, called the Amalthea and Thebe gossamer rings, are named after the moons from which they likely originate. These rings are expansive, yet they are so faint they're almost invisible. So, as we circle around Jupiter, we find a ring system that, while not as visually impressive as Saturn's, is intriguing in its own right. These rings, composed of tiny particles from Jupiter's moons, whisper the tales of cosmic collisions and the ceaseless dance of celestial bodies. Jupiter's rings, though not as famous as Saturn's, hold their own unique charm in the realm of celestial bodies. Each element in our universe, no matter how faint or overlooked, has a story to tell, and Jupiter's rings are no exception. The rings of Jupiter are a celestial mystery waiting to be unraveled. Dive into the enigma that is Jupiter's rings, a phenomenon that has puzzled astronomers for decades. Unlike the flashy rings of Saturn, Jupiter's rings are faint, almost ghostly, making them a challenge to study. They are composed primarily of dust particles that reflect sunlight very weakly. So weakly, in fact, that they were only discovered fairly recently in 1979. But where does this dust come from? This is where the mystery begins. The most common theory suggests that these dust particles are remnants of comets, asteroids, and moon debris that have been captured by Jupiter's powerful gravitational pull. When these celestial objects come too close, they are torn apart, their remnants falling into orbit around the planet, creating the rings we see today. Another intriguing theory points to Jupiter's moons. It's believed that these moons, specifically the inner ones, are slowly disintegrating, their particles joining the dusty rings. In fact, the innermost ring, known as the halo ring, is thought to be formed from dust blasted off the moon Metis. As for the future, there is much to explore. With advancements in technology and the advent of powerful telescopes like the James Webb Space Telescope, the mysteries of Jupiter's rings are slowly but surely being unveiled. Future missions to Jupiter, such as NASA's planned Europa Clipper mission, will also provide opportunities to study the rings more closely. Who knows what secrets they might reveal? The rings of Jupiter, much like the planet itself, are a treasure trove of cosmic secrets. As we continue to push the boundaries of our understanding, we may just unlock the answers to these celestial riddles, shedding light on the intricate workings of our vast universe. Each discovery, each revelation brings us closer to answering the ultimate question: are we alone in the universe? The rings of Jupiter, much like the planet itself, are a treasure trove of cosmic secrets. Our journey through the stormy skies and secretive rings of Jupiter comes to an end. We've traversed the turbulent expanse of the Great Red Spot, the largest storm in our solar system, a tempest so vast that you could fit 2 to 3 Earths within its confines. This storm has been raging on Jupiter's surface for at least 300 years. A testament to the planet's tumultuous atmosphere and the dynamic forces at play. We explored the anatomy of this massive storm, diving into its swirling winds that reach speeds of over 400 miles per hour. It's a maelstrom of gas and clouds, a violent spectacle of nature that's endlessly fascinating. The Great Red Spot is not just a feature of Jupiter, it's a window into the workings of our universe, a tangible demonstration of the enormous energies that govern celestial bodies. Our journey didn't stop there. We delved into the less-known aspects of Jupiter, the elusive ring system. Unlike the prominent rings of Saturn, Jupiter's rings are a whispered secret, a faint echo of dust particles orbiting the planet. We've learned that these rings are made from tiny bits of dust, kicked up by meteor impacts on Jupiter's small inner moons. These rings, though not as visually striking as Saturn's, are no less important. They tell us about the origins of the planet, about the processes that shaped it, and about the cosmic debris that orbits it. Understanding Jupiter's rings helps us piece together the planetary puzzle that makes up our solar system. Our journey to Jupiter is a reminder of how much there is to discover in our universe. The Great Red Spot and Jupiter's rings are not just celestial curiosities, they're keys to understanding the vast cosmic tapestry that we are part of. Thank you for joining this cosmic journey. If you enjoyed our trip to Jupiter, don't forget to subscribe and like the video for more exciting explorations of our universe.